The example 15 in the mathematical proof topic, we've discovered in example 14 some formulae that can help us evaluate the sums of these series here. We want to substitute, instead of having to substitute k equals 1 to 10 into this expression in turn, with just a whole lot of substitution and calculation, we're going to use the formulae to simplify the process. We've got formulae for sigma k squared, and sigma k cubed. So we're going to use all of these in this one. So in order to simplify this, we're going to break it all up into bits. We've got sigma k cubed. We've got a formula for that, so we're going to keep that as it is. For the plus k, 3k squared, we're going to take the 3 as a multiplier, and we're going to then say we just want sigma k squared from k equals 1 to 10. We're going to do the same with the negative 2k, so we'll get minus 2 lots of sigma k from k equals 1 to 10. And see, it's plus 5. You could write the sigma notation, but we know that there's going to be 10 lots of plus 5 written down in that big long list, so we're just going to stick that on at the end. So we've got 3 formulas to bring in here. The first one is the formula for k cubed, which, if you look back at the list, is n squared times n plus 1 squared over 4. And I remember that because it's actually just the square of the formula for sigma k. So that part there is when n is 10, so this element's going to be 10 squared times 11 squared over 4, plus I've got 3 lots of the formula for k squared. That one's a wee bit trickier to remember. It's n times n plus 1 times 2n plus 1 all over 6, which in this case is 10 times 11 times 21 all over 6, minus 2 lots of n times n plus 1 over 2, which is the formula for sigma k. And now if you wanted at this stage, you could just cancel them out without even having to substitute in. And that just gives us 10 times 11. And then we've got plus 50 just sitting there at the end. And we can work all that out. That first 10 squared times 11 squared, and so on, gives us 3024. 3 lots of, again, we could simplify when we're doing our calculations so that we're doing a whole lot less. And we get 1155 minus 110, add 50. It gives us a total value of 4120. So the new bit, the key bit to work out here is the idea of our splitting the original term up into all the different summation of k squared and k cubed, so we can use these formulae. I should have put plus 50 at the end there. My apologies. Okay, so that's how we do it. There's one last one, which is a wee bit more complex. So take yourself over to example 16, and then you'll be an expert.